Hi, my fellow mathematician. Welcome to the study of what is called exact differential equation. So an equation of the form m dx plus n dy is equal to 0 as its general solution of this form of function f, which is a function of x and y, is equal to c, where c is constant. We can obtain the derivative directly from this primitive form. So if we call this equation 1, an equation is seen to be exact if we can obtain it by differentiating a primitive solution. That is, given equation 2, we obtain equation 1 by differentiating equation 2 directly. So that is what is referred to as an exact and differential equation. Now here m is a function of x and y, and also n is a function of x and y. Now how do you test to know whether an equation is exact? So to do that, we consider this primitive equation, and then we find its total derivative, which is given by partial of f with respect to x plus partial of f with respect to y, which is equal to 0. Then comparing this total difference equation, which is a consequence of equation 2, we call it 3. Then it follows that our m is, we are comparing equation 3 and equation 1. So now this is our equation 1, m dx plus n dy is equal to 0. Partial of fx dx plus partial of y dy is equal to 0. So comparing these two equations, our m is equivalent to partial of f with respect to x, and our n is equivalent to partial of f with respect to y. Then from there, we take dm over dy, which is equal to partial second derivative of f, and when we take for n, it will be the partial derivative of n with respect to x is equal to second derivative of f with respect to dx dy. Now, when you compare these two, you compare Roman 1 and Roman 2, clearly you can see that on the right hand side, they are equal, meaning that also the right hand side can be equated. So, we equate them as shown below. So after comparing, partial of m with respect to y is equal to partial of n with respect to x. And this is the necessary and sufficient condition for an equation to be exact. General case for an exact differential equation. So when you are given m dx plus n dy is equal to 0, in order for you to solve this equation, first of all, you let your m to be, you write your m which is in form of function of x and y, and your n which is equal to n function of x and y. Then after that, you test for you find in dm of dy, and then you find dn of dx. Then if dm over dy is equal to dn over dx, then you will know that your equation is exact. So when your equation is exact, your answer will be of the form f of x, y is equal to c, where c is a constant. So that is how you are able to know whether an equation is an exact or not. So in the subsequent presentation, I'm going to give you examples on how to solve exact differential equation. So stay tuned in my channel so that we may learn together. If you have not subscribed to this channel, kindly consider to do so that you don't miss a single video which I upload for you every day. Bye bye, see you in the next video as we look at the examples.